We are on our final page of notes for Foundations of Math 11. We start with an example here. It says two cylinders are similar. The radius of the large cylinder is 3 meters, while the radius of the smaller cylinder is 2 meters. This is highlighted in blue because what we want you to focus on here is that from this information we can get the scale factor. But the question is about surface area. The surface area of the larger cylinder is 54 pi. We are asked to find the surface area of the smaller cylinder. So what we have to do is take the scale factor, and remember the connection to surface area is that the ratio of surface areas is the scale factor squared. The ratio of the surface area of these two cylinders is equal to the scale factor squared. So the scale factor is 2 over 3, and that is simply squared, becomes 4 over 9. So if we want to find the surface area of the smaller one, what we have to do is take our scale factor, multiply that by the surface area of the larger cylinder, which is 54 pi. That simplifies to 4 times 6 pi, which equals 24 pi meters squared. We should have a unit of surface area, and we could leave it at 24 pi. If you put it into decimal form, that would also be fine. Okay, on to example 4. We're told here that we have a can of tennis balls, which usually holds 3 balls. What is the ratio of the air in the can to the volume of the can? Formulas that we're going to need to use here. Balls are spherical shaped, so we'll use the sphere formula. We also should recognize that the can is cylindrical shaped, and we'll be using the cylinder formula later on. And if we analyze the picture, we should recognize that the distance from the middle of the sphere or this ball to the outside is in fact the radius. And if we have that information, we can also determine the height of this can in comparison to this radius. It is 6 radius, one on top of the other, so 6r. So let's look at the volume of the 3 balls. First of all, the volume of a sphere or volume of a ball is given by this formula, 4/3 pi r cubed. If we have 3 balls, we simply have to multiply that by 3. We see that this simplifies, the 3's cancel out, we get 4 pi r cubed. If we move on to the can, this is the formula for the can or a cylinder, pi r squared h. And we don't have h, but we know that h is equal to 6r. So we substitute that in, we get pi r squared 6r. What we want to do is collect the like terms, put the r's together. We see that there's 3 of them all together, and our final answer here is 6 pi r cubed. So if we know the volume of the can and we know the volume of the ball, we can subtract one from the other to get the volume of air, the space that's left inside the cylinder. So 6 pi r cubed minus 4 pi r cubed gives us 2 pi r cubed. That is the volume of air. But that's not what the question is asking. The question is, what is the ratio of air in the can to the volume of the can? So we are comparing this value here to this value here. The ratio of the air is 2 pi r cubed is the value for the air in the can. 6 pi r cubed, which is on the bottom, is the volume of the can. Things simplify. The pi's on the top and bottom cancel out. The r cubed on the top and bottom cancel out. We are left with 2 over 6, which further simplifies to 1 over 3. Quite a bit of work for our final answer. This question would definitely be worth probably 4 marks, maybe 5. Last example here. We are told that a ball of yarn with a 6 centimeter diameter costs $4 and an 8 centimeter diameter costs $8. We're asked which is the better buy. What we must think about to answer this question, it might not be clear right away, but if you think about how much yarn there is in a ball, what we're talking about is volume. So if we're talking about volume, we must use the volume formula of a sphere, which we just used in the last question, 4/3 pi r cubed. So let's look at the small ball and the large ball. First of all, we substitute in the radius. Be careful, because we're told information in the question of diameter, but the radius is half of that, so we don't put in the 6, we put in a 3. Right? 6 is up here, which is diameter. 3 is the radius. We cut it in half. This simplifies to 36 pi centimeters cubed. We do the same thing with the large ball. Remember, they told us information in diameter. We've got to turn that into radius. 4/3 pi r pi, 4 to the power of 3. This simplifies to 256 pi centimeters cubed. But we want to figure out what is the cost. The cost is determined by how much dollars per centimeters cubed. We find out that the small ball will cost 0.0354 centimeters cubed. We do the same type of thing on the right side. $8 for this larger ball, which is 256 pi centimeters cubed. This simplifies to 0.0298 centimeters cubed. Therefore, the larger ball is a better buy. So, just before we wrap this up, I just want to remind us of the formulas that we had used for scale factor. Scale factor is given to us by the length of the image over the actual object. If we rearrange those things, image is equal to the scale multiplied by the actual object. The actual object is equal to the image divided by the scale factor. And if we're thinking about area, it's basically the same formulas, except we are changing scale factor to the scale factor squared. And if we deal with volume, again, the formulas are the same, except we're changing scale factor to scale factor cubed. Hey, here is what's left for the year. We have 8.6 practice questions, which we'll work on in class. Chapter 8 review, Chapter 8 test, year-end review, and our final exam.